Hi everyone. Today we're going to continue with chapter 11.3 and we're going to find the areas of polygons, but the focus today is going to be to use trigonometry and in some cases the rules of special right triangles to find the area of a regular polygon. So let's get started here. And our very first example is to find the area of this regular pentagon with a side length of 18 meters. So again, the word regular means all your side lengths and all your angles are congruent. So every piece of information about that shape is all congruent. All right, so the very first step is we are going to take 360 degrees and we're going to divide 360 by the number of sides, which is 5. And the reason why we're doing this is because we're going to make 5 congruent triangles here. So we're dividing by 5, and 360 divided by 5 is going to be 72 degrees. Okay, so what we're going to do is, the reason why I'm using 360 is we treat this as a circle. So when we take 360 divided by 5, we get the measurement of each of these little central angles here, and that will be 72. So this is what it looks like. So again, remember, you really have 5 of these triangles, and there's 72 degrees at each central angle here. And I'm just going to use one because it could get a little confusing if I leave all the triangles there. All right, so now what we're going to do is draw the apothem. So that might have gone a little too fast. Let me try this again. So you draw the apothem that's straight down, and the apothem makes a 90-degree angle with this side, and it also will bisect that side. So when you draw that apothem, this is what happens. You get half of that 72-degree angle, the one that you see here. 72 now becomes 36. And you get half of the side. The original 18 meter side length is now 9. Okay? And furthermore, this 36, if I subtract away from 90, will give us 54 degrees on this part of the triangle. All right, so now the whole point of us doing this is so we can actually find the apothem. We have the side length, 18, and we have the number of sides, which is 5. Remember, we are trying to figure out 1/2 side times apothem times number of sides. And we've got to get this apothem in order to fill in that formula. So here's where the trigonometry part comes in. So if you recall, so I'm going to use 54 as my kind of like my reference angle here. I'm going to start from 54. Okay, so from that 54, the apothem is actually our opposite, and the 9 is our adjacent. Okay, so remember, so, ka, toa. This gives us tangent of 54. So this is 54 degrees. This is opposite. Tangent 54 is equal to a over 9. All right, and remember, we can cross multiply here. Put a 1 under tangent 54, do a little cross multiplication, and that's going to give us A is equal to 9 times tangent 54, which is approximately 12.38743,728 on your calculator. Okay, now I could have started at 36 and called 9 my opposite, and I could have made the apothem our adjacent. The reason why I didn't want to do that is because then my variable would be on the denominator, and then it makes solving this trigonometric equation a little more complicated. So that's why I added the 54 and just went opposite over adjacent. It's much easier. Take my word for it. Or you can try it the other way and see what happens, but you should get 12.387. And I didn't want to round too early because, again, that does affect your answer. So I left quite a bit of digits here, and we'll round at the very end. All right, so now we're ready to figure out our area of this regular polygon. Remember, this is given by 1/2 side times apothem times number of sides. So plugging all our numbers in, we get 1/2. The side length is 18. Remember, that's the original side length. The apothem, the whole reason why we use trig to do all this was to find this apothem. And this is a pentagon which has 5 sides. If you multiply all that on your calculator, and I talked about this yesterday, if you multiply these 3 values, then take half of that, you get 557.43 square meters. So I didn't say it up here, but we're going to round to the nearest hundredths place. And again, round at the very, very end. Because if you round this to 12.4 and you round a little too early, you'll notice that your final answer will be quite different. So save the rounding for the very end, and this is our final answer. All right, so let's try another problem here. So go ahead and pause the video and go step by step and check back for the solution when you are done. All right, so we are looking for the area of a regular hexagon with a side length of 16. So we already know S and we know N is 6, but we just do not know this apothem here. We're given no information about the apothem. So with that said, we are going to do a little bit of math. So remember, it starts off with a little division problem. So we'll start off with 360. And you always divide it by the number of sides, which is also the number of triangles. 360 divided by 6 is 60, which tells me if I draw 6 triangles on this shape here, we're going to get a central angle of 60 each time. So 60 is all the way around. Okay, sorry for the very sloppy writing, but this is what it looks like for your next step. So there's a 60 there. And now I'm going to chop that into 2 congruent right triangles. So I drop the apothem and I get 2 right triangles, and I'm only concerned with this half of it. So the 60, when you cut that in half, you get 30 degrees. And remember, this 16 gets bisected, that turns into 8. All right, so I'm going to go ahead and fill this missing angle here, and I'm going to write that that's 60. So we have a 30, 60, 90 triangle. And here is where you can use the rules of 30, 60, 90 triangles if you'd like, or you can just go ahead and stick with the SOHCAHTOA. So I'll show you both methods, but here I'm using the opposite and adjacent trigonometry method here. So that's our opposite from 60, and that's our adjacent from 8. So tangent 60 is equal to the opposite over the adjacent, and when we cross multiply as we did before, we'll do that again. I'll put a 1 under here. A is equal to 8 times tan 60. I get about 13.85640,646. Now you might recall this is also the short leg of a 30, 60, 90. And I can multiply the short leg times radical 3. So our apothem is also equal to 8 radical 3, which if you type in your calculator is 13.856. Now this would only work in a regular hexagon, so there's some limitations with the 30, 60, 90 rule. So trig works with all of these regular polygons, so I recommend using that all the time. But you know, if you notice, oh, I've got a hexagon here and I want to use my 30, 60, 90 rules, that's totally fine. All right, so now that we have our apothem, here's our area of our regular polygon formula, 1/2 SAN. So we know the side is 16. We now know our apothem is about 13.856, and we have 6 total sides. So again, I am rounding at the very end. If you multiply all this correctly, you should end up with 665.11 square inches. All right. So let's try this out with an octagon now, a regular octagon with a side length of 10. So hopefully you're kind of getting the hang of this. Started off with 360 divided by 8 sides this time. And again, that's because you've got 8 of these little isosceles triangles here. And you will notice that you get a central angle of 45. So I apologize again for the sloppy writing here, but these will all be 45 central angles. Now, You're not going to use 45 itself. Remember, there's another step that involves you cutting the 45-degree angle in half, because once you drop your apothem straight down, you get half of 45, which is 22.5. 90 minus 22.5 gives us 67.5. And our apothem here is our opposite, and our 5 is our adjacent. So using trigonometry again, gives us tangent 67.5 equals our apothem over 5. And, go ahead and put a 1 under that and cross multiply. 5 times tangent 67.5 gives you about 12.07. And again, I'm going to round at the very, very end. So here comes our formula, 1/2 side length. Side is 10. Apothem is 12.07, 106781, and 8. And we should get 482.84 square feet. All right, so if you get tired of writing the number over again, what you could do is replace the apothem with this. So you could write 10 times 5 times 10 of 67.5 times 8, and then just divide everything by 2, and you'll get the same answer. That way you don't have to repeat this, or you can use the answer key on your calculator just to kind of store this, and you can write everything else out, and then this will just be replaced by answer. However way you choose to do it, you should get 482.84. All right, I'm going to give you one more problem to try out, and this is going to involve a regular triangle, which we all know is not called a regular triangle. It's called a equilateral triangle. And I know you're used to finding areas of triangles using 1/2 base times height, but if you have an equilateral triangle, you can also find it in this way. And we just don't know the height, so we're going to try it using the 1/2 SAN method. There's a lot of other ways to do this, but since we're talking about regular polygons, please pause the video and try your best to find this out, and then check back once you are ready. All right, so again, using the regular polygon method of solving this, we can divide this into 3 congruent equilateral triangles, which means you're going to take 360 divided by 3, which is going to give you 120. So that means our central angles are 120 each. So you have 120 here, and that would repeat for the other two triangles that you're not going to see here. All right, but remember, that's a big isosceles triangle, so when we drop our apothem straight down, we're going to get a right triangle. And cutting that 120-degree angle in half gives us 60. Cutting the 8 right here gives us 4. All right, so I'm going to start from the 30 here, and I'm going to write tangent 30 is equal to a over 4, and do a little bit of cross multiplication. And whoops, one's a little bit too fast here. Sorry about that. We're going to get about 2.309 for our apothem. Now, this is the long leg. This is the long leg of a 30, 60, 90. So if you wanted to use 30, 60, 90 rules, you'd be taking 4 and dividing by radical 3. 4 divided by radical 3 will still give you 2.309. So feel free to use the 30, 60, 90 rules to get to that apothem. All right, so finally, 1/2 side length is 8. The apothem is 2.309, and n is 3. So remember, normally you're used to finding the full height of the triangle, but the apothem just goes from that center, just right directly perpendicular to the side length. So if all is done correctly, or if you totally calculate this the right way, you'll get 27.71 square centimeters. All right, so if you have any questions, please let me know. Send me a message on Schoology, Google Classroom, or an email, and I'll get back to you. Have a great day, everyone.